Let's begin with an example to illustrate the method of completing the square. Consider the expression x squared plus 6x plus 8. As discussed earlier, we can rewrite this by completing the square. To do this, we take half of the coefficient of x squared and add and subtract it within the expression. Now, let's visualize the quadratic function. Completing the square gives us the vertex form. So we know that the vertex would be at -3, -1. We can also see that the curve intersects the x-axis at -4 and -2. Wherever any polynomial function y equals fx intersects the x-axis, gives us the solution to the equation f(x) equals 0. This is also referred to as roots of the equation. How do we find the roots analytically? Let's equate the previously obtained quadratic function to 0. Factorize the left-hand side, or LHS, to get x plus 2 times x plus 4. Now, the LHS equals 0 only when x equals -2 or x equals -4. Thus, the roots of the equation are -2 and -4, as was seen in the graph previously. Now, let's see what happens when we move the graph up or down. If we shift the function upwards, it may touch the x-axis at a single point, leading to one repeated root. If shifted further up, the function never touches the x-axis, implying no real solutions. Thus, a quadratic equation has two roots if the vertex lies below the x-axis, one root if the vertex lies on the x-axis, no real roots if the vertex lies above the x-axis. Let's complete the square for the expression x2 plus bx plus c. The same steps are to be followed. Now, we can see that the vertex of this parabola is minus b by 2a, and this complicated term represents the y value. Next, let's equate the above perfect square expression to 0 and find out the values of x. This is called the quadratic formula. The complicated term inside the square root is same as negative of the numerator of the y value of vertex. This quantity is called the discriminant. This determines the nature of the roots of a quadratic equation. As square root of a negative quantity would be imaginary, there would be no real roots. If d equals 0, plus minus 0 would result in the same root. Otherwise, two roots exist. Please note that a decides whether the parabola is facing upwards or downwards. For real roots, if it's an upward-facing parabola, then the vertex has to be below or on the x-axis. Else, if it's a downward-facing parabola, then the opposite must be true. Thus, if discriminant is greater than 0, two solution exists. If discriminant equals 0, one solution exists. And if discriminant is less than 0, no real solution exists. To summarize, we explored completing the square, graph quadratic equations, and observe how shifting the parabola affects solutions, and derive the quadratic formula. These techniques provide powerful insights into solving and understanding quadratic equations. Thank you for watching. Please stay tuned, and don't forget to subscribe, and share.